and start sharing my screen. And while everybody's taking that important information down, I think quizzes to get back. I don't think Romy was here, Cherokee, Lisa, Bonnie, Anthony, Kelly. Suzanne, you're here. Over there. They don't know. Okay, we are waiting for Terrence to finish that. What? You're still working, yes? Okay, so we won't go over the quiz yet. Before we get started looking at the new content for today, does anybody want to look at any homework problems from my math lab?
About like any problems that I found confusing, but because of the similar notation, I kept getting a lot of questions wrong because I wasn't putting spaces in between my comments, or I wasn't like, there were like spaces and non-spaces, and because it's direct, so I would get questions wrong even though they were the right answers.
Oh dear,
That's something that I noticed.
I'm sorry.
I mean, it's okay, when that one is like, when you get it wrong, it gives you the option to do a similar question. It was just like, I knew, oh, okay, I have to put a space after this column and whatever.
And if you do that, when they show you the right answer, if your answer is right and it's just spacing, that's all, send me an email and I'll give you full credit for it. Okay? All right, because if it's like your answer was right, but for like not hitting a space button or something, I can compare and send me an email and I'll give you full credit. Okay, does anybody want to look at any of the plethora of questions that are up there?
I have a problem with like the ones where you have to find the union and then find the prime of that union.
Okay, those I think were in homework 4. And so in homework 4, yay, it's still in elephant print size. I'm just going to pick a random question. I'm not finding one. There is one like that. Okay, so what this question is asking for is A union B complement. And I guess because this is not a touch screen, it's not going to let me write on the screen, and I do want to write on it. So I'm going to take a minute to rewrite the problem. We've got set A, set B, set C. This is 1, 3, 4, 6, 7, 8, 12, 10, 11, 13, 14, and 19. And I know it's not as pretty because it's my penmanship and it was hurried, but that's close enough to what the question asked for, what the question was. As I look at that Venn diagram, they're asking me for A union B complement. As I look at the diagram, A union B is everything that's in the highlighted region, yes? A combined with B. A union B would be all of that stuff. I never grew up coloring in as fun. Use highlighters, right? Now the complement means, but I don't want that. I want everything else. So A union B is all the stuff that's highlighted. The complement is outside the set, everything that's not highlighted. Thank you so much. I didn't mean to put you on the spot like that. And so what's not highlighted? 14 and 19? So I'm gonna go back here, 14, comma, you said they need a space in there?
14,
Have a space, 19.
comma,
And so let's go ahead and see if we got it. Yay! Did that help?
Yeah, so do you recommend on a test, like if we're not given the Venn diagram, we're just given several way that we draw the Venn diagram?
Yeah, if you want to, you can draw the Venn diagram. Otherwise, you're gonna list all the elements in the union, and then you're gonna compare that union to the universal set. And if it's like a one-shot deal question, cross out the stuff that's in the union and see what's left. All right? But again, a lot of this set stuff did in my scribble diagram. Did the highlighter help?
Yes.
Use colors. Use colors. Circle each given set in a color, you know, the union, you know, the intersection, whatever. And use, you know, get a set of highlighters so you don't have to redraw your picture every question. They're referring to the same diagram. Although I think in my, each Venn diagram is a separate question. On the test, it won't be. On the test, you know, I got a given Venn diagram. And like with the examples that we did in class, we're looking for a lot of things with that one Venn diagram. All right? Anybody want to look at anything else homework-wise?
Can you do question 10? I've been having trouble with the kind of ones.
Yes, you are. Yes, you are. And the door's open on the other side. No, that's fine. How are you doing? Good. And somebody on the phone talked to me. What did you want to hear?
Oh, I've been having trouble with like the same kind of ones. I think it's question 10.
Same assignment, question 10?
Yeah.
So question 10, it's similar yet different. I'm going to project the screen first so that everybody can look at it while I hurriedly scribble it down. We've got that general Venn diagram, A, B, C, and this time it's not labeled with elements, but rather the regions. So we've got our Roman numerals 1, 2, 3, 4, 5, 6, 7, and 8. And it asks the regions that are in a complement. So now I'm going to go back to my crazy drawing. And so a complement, by definition, means what's in the universal set that's not in A. So I'm going to be boring and recycle the yellow highlighter. A is what's inside this loop for A. So everything that's not in that loop is my complement. So A complement would be regions 4, 5, 6, 7, and 8. Everything that's outside of A. Oh no, 4 and 5 are in there. What the hell was I thinking? So how about 3, 6, 7, 8? I got carried away. Bad eyes will write it off too. Sorry about that. Thank you for keeping me honest. Just looking to see if you're awake. Is that better? Person at home, is that better?
Yeah.
Okay. Does anybody want to look at any other homework? If not, where we're going next is what you're going to be doing for your project. We're going to look at how to use a Venn diagram to look at survey results. So we're going to start by using a Venn diagram for survey results. I'm going to write the process out first, and then because survey questions are word problems, rather than writing them up here, I have a handout that I'll share. I think some of you at home picked up the handout last week because you knew you weren't going to be here. If you didn't, I do believe that it's in the handout folder in Blackboard. The first thing that we're going to do is we're going to draw the Venn diagram for the situation.
We can't see it at home.
You can't see at home because I have to apologize. I still have at home my lab. Now can you see it?
Yeah.
Okay, thank you very much for catching that. Draw the Venn diagram for the situation. What do I mean by that? If your survey has 2 questions, it'll be a 2-looper. If your survey has 3 questions, it'll be a 3-looper. If your survey has more than 3 questions, it's outside the scope of this class. We're never going to look at any surveys except those with 2 and 3 questions. Then what we're going to do is we have to make sure that we label everything for the problem. You're drawing this so that somebody can look at it and understand what it means. So label everything with a loop, give each loop a name. Then we're going to, in each region, we're not going to put the elements, we're going to put the cardinality of the region. Oh my gosh, I used grown-up math speak. Can anybody remember what we said last week it meant when we talked about the cardinality of the set? Yeah, the amount of elements. So it means how many things are in there. How many things, usually they're people, not things, but we'll say things, are in that region. When we do this, remember when we fill in a Venn diagram, we're going to start in the center and work our way out. And as we work our way out, what we have to do is we have to remember to subtract the elements in the region already. And then the third thing we want to pay attention to are some key words. And I think we mentioned these keywords last class. We said that the word "and" is like the intersection. We said that the word "or" is like the union. And we said the word "not" means we're taking the complement. And that's what we're doing. And I guess this is clear as mud, and I covered it right down so that you go. You take your time copying it, right? Whether or not the room, getting out copies of the packet. So, let me know when you have that down, and I'll put up a copy of the handout and start working on it. We're not going to do all of them in the interest of time, but we'll probably do 3 or 4 examples. Zoom people, can you still hear us?
Yeah.
Oh, good, thank you. I'm going to just check every once in a while because I got so upset that we lost the audio last week. So everybody got all them their words down? Morgan, do you want me to wait a minute? All right. So I'd like to look at that question at the top of the page. It says, in a survey on musical taste, respondents were asked, do you listen to classical music? Do you listen to jazz? The survey results are summarized in the figure. Okay, let's look at that figure for a minute. Everybody in the survey was asked 2 questions. Do you listen to classical music or do you listen to jazz? Does everybody see the Venn diagram has 2 loops? One loop labeled classical, the other loop labeled jazz. The survey results are summarized in figure 2.27, which is the picture next door. Use the diagram to answer the following question. How many respondents listened to classical music? Classical music is this loop. It's that entire loop. How many people would you tell me are inside that loop? 75? Does everybody see that we've got 55 people in one region, but we've got another 20 people in the other region, so that would give me a total of 75. How many listened to jazz? 90, beautiful. That would be the 20 in the overlap plus the other 70, so that's 90. Next question asks, how many people listened to both? 20, and is everybody all right that listened to both classical and jazz? That's saying and means intersection. What's the intersection of classical and jazz? Again, the intersection is the overlap. So beautiful, that's 20, great. How many listen to classical or jazz? Again, we said that magic word or tells me I'm taking the union of the 2 sets. And when we take the union of the 2 sets, we're taking all of both. So in that union, what would we have? We'd have 55 plus 20 plus 70, which I think adds to 145, and I'm off the page. I'm going to have to zoom out just a little bit. And does that make sense? How many listen to classical music but not jazz? So that would be inside classical, outside jazz. Go ahead and check it. 55, right? That would be inside classical, but not jazz, outside jazz. Those would be those 55 that are just in classical. Then how many listen to jazz, but not classical? Beautiful. That region that's just in the jazz circle, but not the overlap. How many listened to neither? 30. The people who didn't listen to either are those 30 on the outside. And now, how many people were surveyed altogether?
175,
Where are you getting the 175 from?
145, sorry, 145, and everything from classical to classical, and then the 70 from the staff, and the 20 from the mix, and the 30 from the leader.
Is everybody all right? I love that explanation. It's the total of all of the numbers there. It's our entire universe, everything inside the box. And so in terms of reading that, does that show you what the survey results were? How many people felt this way or that way about everything we were concerned with? And it's a nice, concise way of organizing that information in just one picture. So let's go through and let's look at another one, that second one, the one right below. And I do this one every semester because, not gonna lie, the first time I ever did this question, I didn't read carefully enough, and I stood there banging my head against the wall. I couldn't see something. And every time I do it with the class, you guys are much better than I, y'all see it. So let's see how we do with this one. It says, in a Gallup poll, 2,000 American adults were selected at random and asked to agree or disagree with the following statement. Job opportunities for women are not equal to those for men. The results of the survey showed that 1,190 people agreed with the statement. 700 women agreed with the statement. If half the people surveyed were women, how many men agreed with the statement? How many men disagreed with the statement? What I'd like to do before we answer the question is fill in the Venn diagram. When I fill in the Venn diagram, well, first of all, you guys are going to be making your own Venn diagrams, and I do have to apologize. The author of the textbook, when he wrote these questions, it was a much more binary world. And so we're looking at this from that socially incorrect binary perspective. And so is everybody all right? If inside the loop are people who identify as women, they're going on the assumption that outside the loop would be everybody who identifies as a man. Likewise, if inside the loop is everybody who agrees with the statement, outside the loop would be everybody who disagrees with the statement. With me so far? And so if you're doing, in a binary world, a Venn diagram that asks gender, if you are only considering men and women, you don't need two loops. You have one loop for men and one loop for women. So, first thing we know, let's see, we said we got to start in the middle. The middle would be this part, right? That's the center of the picture. That's the overlap. Who would be in that overlap? Women who agree. And so how many women agreed? 700. Now, as we work our way out, the next piece of information that we have is that 1,190 people agreed. So that means the total in the agreed loop should be that 1,190. And you know how I said we're going to start in the middle and work our way out, but we have to subtract who's already in there. Does everybody see we've already got those 700 women in that agreed loop? And so that'll leave us 490 people who agreed that we're not women. With me so far? Now, this is where I was like dumb when I read the problem the first time and didn't see. This region would be the women who did not agree. In order to fill that in, we'd have to have some idea about the total number of women. And so are you guys carefuler readers than I? What's the total number of women surveyed? I'm sorry, I can't hear through the mask. The total is 2,000 people, but go ahead. Yeah, so the total is 2,000. Half of them are women, and so that tells me that we have 1,000 women. Right, and that's over here. Half of the people surveyed were women. And that was the sentence that I missed the first 3,000 times I read this question. So I guess moral of the story, sometimes with Mr. Blitz's questions, read carefully. And so if the women's circle adds up to 1,000, then region 1 would be the 1,000 women minus the 700 who are there already, which would give me 300. Now, we need to figure out the rest of our universe. To find the rest of our universe, so far, between the loops, we have 300 plus 700 plus 490. So far, we have 1,490. How many people were surveyed? 2,000. So don't I need to take the 2,000 minus the people that are inside the loops to get that there are 510 people outside the loops? And who would be outside the loops? The men who disagreed. So now, how many men agreed? 490 people who agreed that were not women. We're going to go on the assumption that they were men. And how many men disagreed? 510. People who were not women that did not agree, the rest of the universal set. Are we having fun? Are we okay? Whether they're fun or not? You doing all right? It's wonderful. Usually I'm teaching this from home, and I'm looking at that Zoom screen with all the little squares, and I have no idea. And so it's wonderful to have real people out here to look at. But I don't know you folks well enough to read your emotions from this much of your face. So it's a lot better. I love that you guys are here, but I still can't tell by looking at you whether it's okay or not. So thumbs up are a wonderful thing. All right, but then I'm going to skip to the back of that first sheet. And I'm going to go up and look at the top one in a minute, but I want to look down at the bottom. So on the second page at the bottom, there's a survey of 250 memorabilia collectors. Does everybody see where I am? Okay. Showed the following results. 108 collected baseball cards, 92 collected comic books, 62 collected stamps, 29 collected baseball cards and comic books, 5 collected baseball cards and stamps, 2 collected comic books and stamps, 2 collected all 3 types of memorabilia. Use a Venn diagram to illustrate the survey's results, because then we want to answer those questions at the bottom. And does everybody realize, just looking at the numbers there, that there has to be some overlap? Because if I added up all of those numbers, it would add up to way much more than the 250 people. So this is where we want to start in the middle and work our way out. Looking at what we were asking people about, what we were surveying on, How many loops do I need this time? 3 loops? So my universal set is going to be everybody who surveyed. And we need 3 loops. One loop will be the people who collect baseball cards. One loop will be the people who collect comic books. And one loop will be the people who collect stamps. Now, I wrote the words out because this is the first of these that we're kind of doing. I'm okay unless they all start with the same letter. If you just label them like B, C, and S. That's one of the reasons I went into math and not English, because it's less words and you don't get to spell as much, right? So, okay. Now, we said we were going to start labeling a Venn diagram from in the middle. Who would be in that very center? The people who collected all 3. Beautiful. And so over here, we're going to put the 2. Now, it's not always the case, but if you're doing these types of problems from Mr. Blitzer's book, you're going to see that usually when we fill in our Venn diagram, we use the material backwards. So the last piece of information was 2 that collected all 3. So that's what I'm going to consider first. And then working the rest of the way backwards, I've got 2 collecting comic books and stamps. Let's see, comic books and stamps would be this overlap, right? That kind of flower petal type of shape. Are there people in there already? I'm looking for where. Colors. I'm looking for where the comic books overlap the stamps. And so does everybody see that overlap would be this kind of region here? We have some in there already, don't we? We have 2 in there already. Do we need any more? So here I'm going to put the 0. Because that whole overlap of comic book and stamps is 2.
So that whole thing counts? Never, not just that little.
Right. When I'm looking for where comic books overlap stamps, I want to pretend that third circle isn't there. I'm just looking at the red circle and the blue circle. And so you see the overlap of the red circle and the blue circle containing those 2 regions. Good question, thank you. Then we made use of this. Next thing we know is that 5 collected baseball cards and stamps. Well, stamps is pretty blue. Baseball cards, if this pen works, is, oh, it's not green. Is it green? I guess it's sort of green. Baseball cards is that green. And so I'm looking for the overlap of baseball cards and stamps. And so wouldn't that overlap be this region here? Are there people in there already? 2, but we need to have 5. So I'm going to think 5 minus 2 tells me that that region will have 3. And you see how I'm taking the numbers that are inside and subtracting them as I work my way out. So then, next thing that we've got is 29 collected baseball cards and comic books. Baseball cards, green. comic books is red, so that overlap would be this region. Again, those two people are in there already. So don't I need to take the 29 minus the two that are in there already? And so this would be 27. Does that make sense? Great. Now, next thing that we know is that 62 collected stamps. So the whole stamp circle has to add up to 62. How many people are in this stamp circle already? 5. So we're going to take that 62 minus that 5 and say that that leaves me with, somebody check my subtraction, I think it's 57. Thank you. Then we know that the total of the comic books is 92. So let's see, for the comic books, we've got 92 people. And how many people are in the comic book circle already? 29, beautiful. And so when I take that 92 minus that 29, I think I get 63. And so finally, there's 108 that collect baseball cards. But in baseball cards, we have 3, 2, and 27, which I think adds to 32. So that gives me 76 here. And yeah, I should have said the 63 and never wrote it. I'm sorry.
But we're not done yet.
We haven't used all of the information. What we did not make use of was that there were 250 people at whatever that were surveyed. So if I add up all of these numbers, and I'm going to cheat a little bit. I know that that one adds up to, the baseball adds up to 108. And so I'm going to add the numbers that are outside, the 63 and the 57. So that's 328. I think somebody check my arithmetic, please. No, 228. Hello, 228. Somebody check my arithmetic. Does that add up to 228? Yeah? And so for the rest, we know that there's a total of 250. And so when I subtract the 228, I get 22 people outside. And now that we've got everybody in their little cubby, got everybody organized, we can answer the questions below. So A asks, how many people collected comic books, but neither baseball nor stamps? 63. Is everybody comfortable? The people who got just comic books and none of the other stuff was 63. Next asks, how many people collected baseball cards and stamps, but not comic books? Again, remember that and means union, not comic books means the complement. So we're looking for the union, I'm sorry, and means intersection, I apologize. The intersection of baseball cards and stamps, but we want to be outside of comics. Wouldn't that be our 3 people here? Does everybody see these 3 are in the loop for baseball, the loop for stamps, but they're outside of the loop for comics. Baseball cards or stamps, but not comics. Well, or is like taking the union of baseball cards with stamps, but we want to stay out of the comic book. So wouldn't that be my 76 plus my 3 plus my 57, which I think is 136? But somebody check my addition, please. I think 6 and 7 would be 13. I'm okay? I should just use my calculator that's in front of me, right? Okay, exactly 2. What numbers represent the people who collect 2 things? Wouldn't that be the 3, the 27, and the 0? Wouldn't those be the regions for 2 people? For people not, I'm sorry, not 2 people, people who collect 2 things. Now, another phraseology you're going to see is this at least 1. And when they refer to at least 1, at least means 1 or more. And so at least 1 if that's, 1 or more. The people who collect 1 thing would be the 76, the 63, the 57. The people who collect 2 things are the 3, the 27, and the 0. And the people who collect 3 things are the 2. And if I'm not mistaken, we already added those and got that 228. And so how many people didn't collect anything? 22. Those folks that are outside the loops. Does that make sense, or does anybody want a slow motion replay on any of it? If that makes sense in terms of the survey question, what I would like to do is now scooch up to the top, and I only want to look at one of those 2. And so I'm going to cross out question number 27, because if anybody has a book, the odd numbers are in the back of the book, so you can try 27 on your own and check it, but the even numbers aren't. And I don't know if I've said this before, it might not be exactly the same book, but if anybody just wants the access code and not the book, because it was cheaper, that's what I would do too. But I've been teaching this class enough that I probably have several back editions. So if anybody wants a paper book, just let me know and I'll get one from my office for you, okay?
I was wondering if some that was supposed to bring in, some that there wasn't.
Okay. Do you want a book? If you guys want a book, when we take a stretch out legs break, I will run up to my office and just let me know how many, put your hand up in the air if you want a book. So 1, 2, 3, 4, 5, let me see if I have 5 ancient books. 6 ancient books in the office, okay? So, but let's go and let's look up here at 28. And you guys know that you have the digital book, right? Did I show you guys where you have the virtual book?
Oh, yeah,
It's in the My Labs. We'll look at that in a minute. So, 28. Yeah. So in the accompanying Venn diagram, it shows the number of elements in region 5. In exercises 27 through 28, we're just going to do 28. So in exercise 28, use the given cardinalities to determine the number of elements in each of the other 7 regions. And I did put one of these in your homework because, again, it goes back to what we were saying, that when we fill in a Venn diagram, we want to start in the middle and work our way out. When you do this question in My Labs, it's gonna have those other regions, 1, 2, 3, 4, we know 5, 6, 7, and 8. And they're gonna be in that order with, you can see why I teach math and not art, blanks to fill in. And I think the biggest mistake that I see is people see that region 1 is at the top of that, so that's where they're gonna start. Make a sketch, fill in your own Venn diagram. Remember, we're starting in the middle and working our way out. And so, starting in the middle, I know that region 5 they gave us has 2 people. And again, it's silly, but usually with Mr. Blitzer's questions, we're gonna start at the end of the question and work our way up to the top. So here we know that the intersection of B and C contains 8. The intersection of B, this loop, and C contain 8. So that whole region has 8. Does everybody see those 2 in there already? So I'm going to take 8 minus 2 and get 6.
Why did you just put it there, like, what makes, oh, because it doesn't, never mind.
Okay. Then we want the intersection of A and C, the intersection of A and C. So that's this section. It's supposed to have 7 in it, but there's 2 in there already. And so when I take 7 minus 2, I get 5. And I'm going to use a color here so that it pops a little bit, or is that harder to see? Does the blue pop, or is it harder to see? Then we know the intersection of A and B. A and B, this entire intersection has 6. So don't I need to take 6 minus the 2 that are in there? And so this would have 4. Now, the whole circle of C is supposed to have a total of, I just saw it, 14. How many are in C already? Don't we have 5 plus 2 plus 6, which is 13? And so this region would only have 1. How about B? Can you guys tell me how many things are left over in B if the total of B is 15? I think I heard through a mask 3. Thank you. And now lastly, no, it's not lastly, I apologize. Next, A has 21. But inside of A already, we have the 5, the 4, and the 2, which gives us 11. And now the whole loop is supposed to contain 32. Right now in there, I've got 10, 4, 3, 5, 2, 6, and 1. So what is that? 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 31. So I must have one more person to get to my 32. And now, because we started in the middle and worked our way out, now we can fill in the blanks. Region 1 has 10, Region 2 has 4, Region 3 has 3, Region 4 has 5, Region 5 we knew already, 6 has 6, 7 has 1, and 8 has 1. And so I wanted to make sure that we did something like that with, just like what we did with stamps and the baseball cards and the comics, but they've got the intersection symbol instead of and, and the union symbol instead of or. And so we can go through and fill in. But I wanted to make sure everybody was like real comfortable with the idea. We start in the middle and work our way out. And as we work our way out, we have to subtract what's in there already. All right? So, if that's okay, next place that I'd like to go is to walk you through your project. And those projects are going to be due, next week. If it's problematic for you, let me know, and by the time we email you, and how much you think, and we'll push the area. Yeah. My best topic to count myself. And usually I go for one early in the morning, but when it's like 25 or lower, I'm just so afraid of black ice because when it's so cold, you just can't see it. So as the semester is progressing, I'm getting bigger and bigger as the winter is progressing. Oh boy. All right, so Chapter 2 project. This is an activity is intended to provide practice in the use of Venn diagrams to sort responses to a survey. Have to apologize, I stole this project from the textbook, so it's not quite all my phraseology as Mr. Blisters. Decide on a topic for your survey. Whatever you want, whatever interests you. I'm hoping that if you can use this information, this process with something that holds your interest, it'll take on more meaning for you. So you're going to devise 3 questions that you're going to ask people. But be careful. You want your questions to only have 2 answers. Oh my God, I had a student one semester who was so hot. And they asked everybody what their favorite color was. And if you can think of like favorite colors, they had, they had 20 people, they probably 12 different responses, right? And they were going to have to put it in Venn diagram. And I'm like, no, you can't do that. Venn diagram. So if you're interested in people's favorite color, don't ask what your favorite color is. Ask, is your favorite color blue? And then you've got 2 answers. People either like blue or they don't. Or if you're asking people how old they are, if I ask what your age is, I could possibly get a different answer from everybody in the room. So instead of leaving it generic, how old are you, I might ask, are you 20 or older? And if you're 20 or older, stay older. And if you're under 20, you're outside. So make sure that your questions are sort of categorical and either your respondents are in or they're out. Interview at least 20 people. Okay? I'm not asking you to avoid all COVID regulations and go face to face and ask 20 people. You can do it like, use social media or whatever, get 20 responses. Okay? And then the next thing is to construct a Venn diagram to sort the answers to the questions. You're actually going to make 2 Venn diagrams. One Venn diagram, you're just going to label who belongs in the region. And then the second Venn diagram, like we did with the survey questions, you're going to label this the cardinality. This is a 25-point project, and so there are 5 points. Just to give me a sentence, my questions are, and this is your 3 questions. There are 5 points for the record of the responses. So just in case people, I think I'm saying this out loud, make up the responses, make up names. People. If you're worried about confidentiality with your respondent, then I guess you can just number it. But show me the list of 20 folks that you ask. Then your 2 Venn diagrams. Each Venn diagram is 5 points. 5 points to the first Venn diagram, 5 points to the second Venn diagram. So that adds up to 10 points. And initially, when I started these projects, a long, long time ago, there was this big push for writing across the curriculum, where they wanted people to write in all of their classes. And so this is where the writing comes in. Last 5 points, I want a brief summary of what you did. Okay? And it can be very brief, a paragraph. I asked 20 people this questions, I went through and I sorted the responses, and I thought this was up, whatever was interesting. All right? And then I made, the rest of the project sheet is an example that I made up. So, example that I made up. My questions were, and again, I apologize, this was in a binary world. What's your gender? Are you 20 or over? And do you take a math class? Because what more would you want to know about somebody than whether they were taking a current math class or not, right? And so I cheated. I only did my list of 2, but this list should contain your 20 names, the question, and the answers. Then 2 Venn diagrams. My first Venn diagram, I don't have any, well, I guess I'm lying when I say I don't have any numbers in it because I'm at the age of 20, but I don't have any cardinalities in it. And so in my first Venn diagram, this loop is males. So everybody inside this loop is a male, which means everybody who's outside that loop is not a male. This loop are the lucky people who are taking a math class. Everybody inside this loop will be taking a math class. Anybody who's not taking a math class will be outside. And this loop would be the people who are 20 or over. Everybody inside this loop is 20 or over. Everybody who's outside that loop is very much younger, and I'm extremely jealous of them. Whoops, did I say that out loud? So, regions then. This region here would be, it's inside males, it's inside 20 or over, it's inside math class. And so that itty-bitty typing says it's males 20 or over in a math class. Over here, this region here, it's outside of the men, so it's females. It's outside of the 20 or over, so they're under 20, but it's inside math class. And you see how I've taken each of those regions and labeled descriptors of who we go to. Okay, I typed it because I have bad penmanship. Please, unless you really love taking a lot of time typing over diagrams, that's a pain in the ass. I'm perfectly fine if everything is hand-drawn. I'm perfectly fine if you can't write everything. If you want to type it, you can. And I'm going to allow people with good typing skills. But if you want to draw it by hand, that's perfectly fine too. And so that would be my first Venn diagram. And then my second Venn diagram would be that same diagram, but instead of putting the words, I'm putting the numbers from my system. Okay? And then write a paragraph. You know, I asked 20 really cool people how old they were, what gender they identified with, and if they were taking math. And I found it really exciting that, I'm making things up, there were the same number of men, no, let's take that back, that there were Oh, yeah, no, there are more women in math than men, right? Because there's 7 men in math and 8 women in math. So that would be something cool to say about it, right? Never mind. Do you get the idea of the project? Okay. Then, I've got that it's a little bit after 7, and we kind of go until, we're supposed to be going till just about 9. Do you guys need a break now, or should we hold off for a little bit? Do you guys want a 5-minute break, or no? Just keep going. All right, then if we're going to just keep going, that's the end of the unit, and I need the spacing of it because, while we just did the survey stuff today, we're going to give that chapter test next class. What I am going to do, though, is I promise the test will be at the end of class. And so if you have questions on anything, bring the questions with you. And so I have this practice test. I was now rethinking. I need your input, folks. Do you want to go over this practice test today, right now? Or do you want to take this practice test home, do it on your own, and then do it at the beginning of the next class, the time you will be before you get to that? I'll leave it up to you, which way you prefer. To go over it today, or to go over it before you take the next class. Does anybody have a preference? Today?
I think today you get a better understanding.
Great. Then let's go over it now. Except there were a few people who took copies of them before they left last week. And so I think I just gave out all of the copies. And, oops, wait. No? Do you have an extra one? Oh, thank you, because otherwise I'm going to run my office and burn the copy. Today's a technology challenge type of day. I have to apologize. On the test itself, these are much more spaced out, but when I make the paper copy, I was trying to be environmentally correct, and so they're a little bit mushed together, and I apologize for that. So, first thing, we're going back to the beginning of the chapter when we talk about what is a set, and we look at sets in different notations. And so first thing is express the following using roster notation. First of all, does everybody remember that if I'm using roster notation, it means I'm putting braces and I'm putting my elements in there with commas in between. And I won't make you redo it if you don't put a space, right? So as I write them with commas in between, does everybody remember this set we're representing with the letter X, the set of all variables X, where X is a natural number. Remember, our natural numbers are our counting numbers starting with 1. And let's see, 3 is less than X is less than or equal to 9. So at its very basic, can everybody see that the numbers that I want are in between 3 and 9? Because X is in the middle. Do I include 3? No, I don't include 3 because there's no equal sign underneath. So I'll have 4, 5, 6, 7, 8. Do I include 9? Yes, because there is that equal sign there. And so if it's presented in an inequality, if your variable's in the middle, you want the numbers in between. If the little line is underneath, it can equal that number. If the little line is not underneath, it cannot equal. Now, question 2 says A is the set of all x such that x is a natural number and x is less than 5. So let's see. Usually when I see something like that in set building notation, if I can, I try to list the set. It just makes things clearer for me. So I want counting numbers. We'll start with 1, smaller than 5. Am I including the 5? No. So that's the set 1, 2, 3, 4. B is the set of all x such that x is a vowel. Okay, what are my vowels? A, E, I, O, U. Are those sets equivalent? No. Why not? Beautiful. They don't have the same number of elements. So the answer is no. They don't have the same number of elements. Remember, equivalent is different than equal. And so we want to worry about the number of elements that they have. The number of things in set A, remember that little n in front meant number, cardinality. The number of things in A is 4. The number of things in B is 5. Those numbers are not the same, and so they're not equivalent. I can't play matchy-matchy and give everybody in one set a partner or the other. There are leftovers, which is so sad, but. Now, next one, there is more than one correct answer, but I'm only going to ask you guys to give me one correct answer. We're comparing the letters in the word carpenter to the letters in the word car. I'm sorry, I can't hear you through your mask, and I know you're saying wonderful things. You want to pull it down and talk loud for a second?
You can use the one with the key underneath because it adds numbers in the other as well. And then you can do
This one and this one. Okay. I get where you're coming from, but over here, carpenter has C, A, R, P, E, N, T. We don't have to repeat. Here, car has C, A, R. Now, if I put the C in here, are all of these letters? No. So that one's going to be the C with the slash in it. If they were in the other order, if instead I would have had C, A, R, and C, A, R, P, and T, that I can put, because think of that being the letter C, representing the word contained. Okay. So these letters are contained in this one, as opposed to if I've got the bigger set first. Not all these guys are in there. So you right idea, but backwards.
The order doesn't matter.
It matters which set is on which side. But over here, if I wanted to spell arc instead of car, it would be perfectly fine. Inside the set, it doesn't matter. But in terms of which side of the symbol you're on. Okay?
Then I was looking at it, referring to question 4 that we're about to do.
Okay. And so 4, are these guys all in here? Yeah, so I can use the regular subset symbol, Or I can also use that proper subset symbol, because those two sets are not exactly the same. The regular subset means it's contained in and it's okay if they're equal. The proper subset is not okay. All right? And so the way I kind of keep those two symbols straight in my mind, scrap paper, scrap paper, scrap paper. In my mind, the relationship between subset, proper subset and subset is very similar to the relationship less than or equal to. With this symbol, it's okay if they're equal. With this symbol, it's okay if they're equal. With this symbol, it's not okay if they're equal. With this symbol, it's not okay if they're equal. And so in my mind, that line underneath with the subset notation is exactly the same as that line underneath with the inequality notation. And it's not going to lie, that's the way I've always kept it straight. Okay, this one's 1, 2, 3. And what's in here? The natural numbers less than 4. What would be the natural numbers less than 4? 1, 2, 3. Yep, so those are equal. And I guess if you really wanted to, you could also put the subset with the equal underneath, right? Because they are equal. What's that symbol mean? That symbol means the empty set. And so this is one that I know some people sometimes have a hard time remembering. But going up to the top, does everybody remember the reason this one was not a subset was because it had too many things in it? Does the empty set have any extra stuff in it? No. So the empty set is actually a subset of every set. Because it doesn't have any extra stuff in it. All its stuff is in there because we can think of the content of the empty set like being that space between the comma that they want to make sure we put in there. And so there's always space inside any set, before the comma, right? Oh boy. Now this one is tricky, and it was tricky because the first time I typed it, I made a typographical error. As I look at 7 on the left-hand side, does everybody see 7 is not a set? It's a thing. It's not in braces, so it's not a set. It's a thing. Now when I look at the right-hand side, does everybody see that right-hand side only has one word in it? And so we're going to say that it's not an element of, because there's only one element in that set on the right, and it's a word. However, 8, here we've got one thing, E. Here we've got the set with A, E, I, O, U. Is E inside there? So we are going to use that element symbol. And remember, if I'm looking at things without the braces, I'm just looking at the elements. So it's going to always be the E-looking symbol, and not the subset one. And then this last one, the first set is 1, 2, 3, 4, 5. The second set, what would be in the second set? Numbers. Let's look at that. We're saying X compares like this to 10. Are we saying X is smaller than 10, or are we saying X is bigger than 10? It's bigger because you guys all saw the inequality. It's a mouse and it always wants to eat the bigger. So X is bigger than 10. And so that's going to be 11, 12, 13, 14, and It's a lot of fun making that list, but I don't want to spend the rest of my life doing it, so I'm going to put my ellipsis in there. Are these guys in here? So it's not a subset. Question number 10. What's it mean? This is set Q. Set Q has the letters M, A, T, H. What does the little N in front of the Q mean? It's natural number, it's the number of things in there. It's the cardinality. So how many things are in this set? 4. When that little N is there, it's telling you that your answer is a number. Next, I want to know, how many subsets does it have? And remember, last class, it was kind of time-consuming. You had 1 element, we listed all the subsets, 2 elements, we listed all the subsets, 3 elements, we listed all the subsets. And we noticed that the more stuff that was in there, each time we added an element, it doubled, which reminds me that it's that formula 2 to the nth power. So that would be 2 to the 4th. So think 2 times 2 times 2 times 2, which would give me 16. Proper subsets, it's always 1 less because we're just taking that entire set out. All the other subsets that are not equal will be in there. And then, yeah, I did put one on the test that asks you to list all the subsets. So again, when I create a list, it helps me to know how many things I've got to make. And so first of all, this set has 3 things, so I should have 2 to the 3rd or 8 subsets. And so there's nobody there, but I feel like I can't see everybody because I'm too damn short. And it doesn't let me move. I wore heels last week, and so I could see over it, but my boots are here. So I keep jumping up and down to look at you. So anybody want to give me one subset of PIG? P, beautiful. Another one? I, another one? G, another one? Just the empty set. Another one? PI, pi is a really fun math word. Another one? PG, kind of like the movies. Another one? IG, like my cousin Iggy. So now we've got 1, 2, 3, 4, 5, 6, 7. We're missing one. Beautiful, the set itself. And again, it would be perfectly fine if you put those in a different order. And I'm moving it over for the folks at home because the list of people who are in the Zoom meeting was on top of the paper. Okay, 14 asks us to draw a Venn diagram. So I am going to give you folks a couple minutes to draw that diagram on your own. And I'm going to run up to my office real quick and see how many books I have. So I will be right back. See if you can draw that diagram and answer the question. only find 4 in my office, and 3 of them are hard copy. And I know I have at least 1 at home that can be mine. So I only have 5. The page numbers might be different, but the content should be the same. They're just back editions. I will look through my bookshelf at home and see if I can scrape up a couple more. So they're there for the taking, and I don't want to play mom and decide who gets it and who doesn't. So we'll just leave it as they're there for the taking and how desperate you want to have that physical book in your hands. Again, in a couple minutes, I'll show you where that virtual book is. So, how'd your Venn diagrams go? Universal set, set A, set B, set C. Start in the middle. Let's see. These both have C and D. There's nothing common to all three. Nothing in the middle. Middle's in. No, there's nothing in the middle. So now let's go over here. What do A and B share? They both have C, D. What do B and C share? They both have E. What do A and C share? A. Okay. Are we missing anything from set A? We've got A, C, D. We need B. Beautiful. Set B has C, D, E. We need F. Awesome. Set C has A, E, H. Great. And the universal set has A, B, C, D, E, F. Up, we need G. It's always much easier if you sing the alphabet when you put them in. Okay. So now, yes, the dreaded apostrophe, A prime. Again, if that prime is there, it means the complement. And the complement of A is outside of A. Okay, little kid in me, when I've got the Venn diagram, if I want A complement, I put my thumb over everything in A and say, what am I not covering up? E, F, G, H. U is for union, like a labor union. We're putting everybody all together. So we're taking everybody in set A. So everybody in set A is my A, B, C, D, and adding everybody in set B. In set B, C's in there already. D's in there already. I need to add my E and F. Or, again, the union, putting them all together is kind of like that big sideways snowman formed by the two loops. That one I'll write. A complement union C. Okay, A complement, we did A complement. A complement is E, F, G, H. A complement is all the stuff outside of A. If we're taking the union, we're adding to it. What are we adding to it? We're adding everything inside of C. So we have to add the A, and the E and H are in there already. Does that one make sense? outside of A is, E, F, G, H. When I union it, I want to add to it everything fits inside of C. C is A, E, H. We got the E and the H already, so we need to add the A. Okay, health, A intersects B. What's that one going to be? C, D, beautiful. The overlap. Just like the intersection of two streets where they cross, where they overlap. Oh dear. This is kind of like, I think, the type of question we were looking at the start of class. In math, if there's parentheses there, you do inside the parentheses first. So inside the parentheses, I have A union B, which is this whole mess here, or inside the parentheses, A union B was everything inside that sideways snowman, A combined with B. But I don't want what's in A union B. We've got the dreaded prime outside. That apostrophe is important. It tells me I don't want what's in the set, but rather I want what's out of the set. H, G, and actually this C is the name of the set, it's not this thing, so it's just H and G. Okay, it's a pencil and paper test, it's not a MyMathLab test. I like pencil and paper tests better than MyMathLab tests. That's one thing I hate in all of my Zoom classes, because they're almost all getting MyMathLab tests. The reason I like pencil and paper tests better is because MyMathLab, you got it right, or you got it wrong. Pencil and paper tests, there's gobs of room for partial credit. So each of these, I think, are like these shorter answer ones. They're all worth like 2 points. And so if you just put the H and not the G, I'll give you one of the 2 points, right? With these, if your set is off by 1 element, you'll get half credit, okay? And again, the more work I can see as we get into the higher credit problems, the more partial credit I can give. So now this one asks for first A union C. And so A union C, getting my highlighter out, A union C is A combined with C. So A union C is everybody in there. But we want its intersection with B. And so if I look where the highlighted 2 loops overlap with B, does everybody see it would be C, D, E? Beautiful. And then this last one is a tricky one, because inside the parentheses I've just got A. But what does that little N in front mean? Natural number. I want the number of things inside of A. So when I look inside of set A, how many things do I have? 4. And remember, if it's that N in front, your answer is a number. It's not a set, it's a number. Great. Down here, it's the same general idea, but the Venn diagram is drawn for you. And so down here, A, inside of A is everything in this loop. A complement, if I cover that up. Outside of A is 2, 3, 4, 9, 10, 11. And it's okay if you didn't put the numbers in order. I just did because. But as long as those numbers are there, you're good. Next one, we want A intersects B union C. Again, B union C is where I take the loop for B, the loop for C, and put them together. So everything inside that is B union C. If I want its intersection with A, where does that overlap A? Beautiful, 816. Oh, and as you said, that 816, I'm feeling really remorse. Whoops. First of all, let me move this up a little bit. I should have interchanged some of those numbers so that answer would have been 716. But here it is. Never mind. 816. Okay, so now we want B intersect A. B intersect A. Okay, B intersect A is where B and A overlap. That's 6, 1. So we want that intersection union. So, okay, we're going to take all of those, and union we add to it. What are we going to add? Everything inside of C. So inside of C, we have 8, 1, 11, 4. 1's in there already, so let's add the 8, 11, and 4. Am I just talking at you guys, or does this make sense? Makes sense? Good. So what's this last one that 25 asked for? It's just one in a set because it's asking where the 3 loops overlap. Beautiful. Now this one asks for a couple of things. A intersects B. Okay, so that's the overlap of A and B. So the overlap of A and B is 6 and 1. A intersects C. The overlap of A and C is 8 and 1. And if I'm taking the union of those two, doesn't the union mean I'm putting them together? So that again is my 6, 1, and 8. And then the last one, what does A have in common with nothing? Nothing. It's the empty set, and you can write it either way. Make sure, though, you either use that 0 with a slash for the null set or the empty brace. What does it have in common with nothing? Nothing. How's the first side? Good. Next one is one of those proofs where you use the general Venn diagram. I did not draw it on this. It's drawn for you on the test. And so we have that general 3-loop Venn diagram with A, B, C, and I use Roman numerals. Again, I think I told you guys when we were doing these in class, if you really don't like Roman numerals, I'm perfectly fine if you write over them with plain old numbers, if that's easier for you to work with. But you've seen these questions in my labs using Roman numerals. And so on the left, we want to know set and region, what's inside A complement intersect B union C. And I think when we did these in class last week, we said the more work you show, the more partial credit you can get. I'm going to condense a little bit this time just because I'm short on space here. First of all, let's look at A complement. What Roman numerals are outside of A? Outside of A would be 3, 6, 7, and 8. Then if I look at B union C, if I combine B together with C, B union C would be 2, 3, 4, 5, 6, 6, and 7. And so when I take A complement intersect B union C, I'm taking the intersection of these. So I'm saying, what do those two have in common? And let's see, it looks like they both have 3. It looks like they both have a 6. And it looks like they both have a 7. And now we want to see on the other side what's in A complement intersect B union A complement intersects C. A complement intersects B. So that's outside of A, inside of B. Outside of A, inside of B would be 3 and 6. Next, we need A complement intersect C. A complement outside of A intersect C. So what's outside of A, inside of C? Outside of A, inside of C is 6 and 7. And so finally, if I take A complement intersect B, union A complement intersect C, when I take the union, I'm just putting those together. So putting them together, I have 3, 6, 7. And so the question's asking me to compare the bottom line. When I compare those two, are they the same or different? They're exactly the same, aren't they? So since they're the same, we're going to say yes, it's true. And so it's kind of like what we were doing with the Venn diagram, but instead of putting the elements in there, we're putting the Roman numerals, which are supposed to represent the region. Two more. Question 25 says, a survey of 1,200 American adults was taken to analyze their investments. Of those surveyed, 650 were invested in stocks, 550 in bonds, 300 in both. How many were only in stocks? How many were in stocks or bonds? How many did not invest in either? Anything we can do to make those questions easier to ask? picture's worth 1,000 words, right? So, picture's worth 1,000 words. How many loops does this Venn diagram need? 3? What would you call them? I'm thinking we can get by with 2. I'm thinking one will be stocks. The other will be bonds. When I fill it in, I start in the middle. What number should go there? I think I heard 300. Beautiful. Now, all of bonds is 550. So how am I going to find out the number for here? Beautiful. 550 minus 300 gives me 250. You guys are awesome. Likewise, we know that 650 invested in stocks. So over here, beautiful, subtracting would give me 350. Am I done yet? No, because the whole box has to add up to 1,200. And right now, 350 and 250 is 600 and 300 is 900. So when I take the 1,200 minus the 900, I have 300 left over. How many invested in just stocks? Beautiful. How many invested in stocks or bonds? Remember that or is the union. 900, beautiful. And so how many didn't invest in anything? 300. And so that's showing the work, and these are the answers. Just a good picture, make the questions easier to answer. And then, last question is one of those big survey questions. Like the survey question we did with the cars, like the survey question with the classical music and all of that. But this time our survey deals with winter resort activities. Now, on the test, I asked you to draw the Venn diagram, and then I asked you to use your Venn diagram to answer the question. Which I guess in some ways would be really bad if you made a number mistake in your Venn diagram, then all your answers are wrong. But that's not the way I'm going to grade it. If you make a mistake in your Venn diagram, I'll take the points off in the Venn diagram. But if your answer is correct through the diagram that you drew, I'll give you full credit for that. Because the question has 2 parts to it. One is making the Venn diagram, and the other is reading the Venn diagram. And when you read the Venn diagram, you can only read the one that's in front of you, but not the one that I taught you. Okay? So make sure you draw your Venn diagram. Do you folks want to try to fill in this one on your own? Or do you want to do it together now? Or do you want to do it on your own at home during the week and go over it next week? Leave it up to you. I'm sorry, I couldn't hear you. Do it together, did you say? Or did you say do it on your own? I couldn't hear you. Do it together? Okay, what should I label my loops? Ski, snowboard, and I think ice skate. I'm going to call it ice instead of skate so that it doesn't begin with S again. Who goes first? Where do I start? In the middle, what number goes there? 2, because 2 liked all 3. Working my way out. 2 like to snowboard and ice skate. So that's this overlap. So what number should go here? 0. Beautiful. Then 15 like to ski and ice skate. Ski and ice skate. So this overlap. Beautiful. 49 like to ski and snowboard. So what goes here? 47, beautiful. 57 like to ice skate. So the whole circle for ice skate is supposed to be 57. Go ahead. Good question. We're told that there's 2 that like all of them. And then we're told that the overlap of snowboard and ice skating is supposed to have 2 people in it. There's 2 people in there already. So there's nobody else here. If you want to leave it blank, you can. Okay. 57 like to ice skate. Inside there, we've got 15, so that leaves me with 42. $154 like to snowboard. What should I subtract from there? 49, and so that gives me 105. $178 like to ski. And let's see, we've got, is that 62 inside? So there's 106 here. What number goes there? Use the big bad calculator. Let's see. Woo. You take 106 plus 47 plus 10. What are you getting? 35? I'm remembering it as being different, but I could be wrong. Oh, yeah. That's 116. Okay. Thank you. I was adding in my head too, and I apologize. You guys probably have better arithmetic than me because you've all got much younger, sharper minds. So yeah, because I remember that answer as being 25. And you were right for my arithmetic mistake. And so if I would have left it as 106 and the other number is 35, all of the answers afterwards would have been wrong. But again, if I put the right answer in the future, then I knew what you needed to correct. Okay? So, how many liked exactly one of these activities? One activity, it could be skiing, boarding, skating. Yes. And I'm not going to do any more additions tonight. Tell me what you guys get. That's what I got. I lied. I can't help it. I have to answer. How many didn't like any of them? How many liked at least 2? Beautiful. I think it's 62 though. We have to add those numbers. Don't be sorry, because I just did that same type of mistake, so everybody can be off by 10. No. So that adds to 62. How many like to snowboard and ice skate, but they didn't like to ski? Was there anybody who liked to snowboard and ice skate but not ski? No. How many like to snowboard or ice skate but not ski? Or,
29 is 0.
yes, 29 is 0.
Well, it wasn't it supposed to be 2, even though the 0
Be-
there, or?
Well, the people who like to both snowboard and ice skate are here. But then we don't want the people who don't, we want the people who don't ski. So we're taking all the skiers out. And so if I look for the complement of skiing, so 30 would be the 105, the 0, the 42. But again, we want to stay outside of that skiing loop. So that's 147. Oh, geez, I'm redundant. How many likes none of these? 25, we said that already. How many like to just ski and nothing else? 116. And then this very last question that's kind of over here in the corner. It's an extra credit question because it's a little bit different. It's extra credit because I'm asking you to think above and beyond. I'm asking you to describe, using the symbols union, intersection, complement, ABC. I want you to describe what's shaded. Sometimes I think it's easier to answer a question by saying what's not shaded. What's not shaded is most of C. So that's C complement. But then go ahead. Union, I'd like to, union, how about union B? Aren't we taking outside of C and we're putting B back in? Again, don't lose sleep over that question. It's an extra credit type of question. The one on the test is a little bit more obvious than that one, and there's probably more than one way you could have done it. But what's shaded is outside of C plus that little bit, plus adding what's in B then. All right. And I've got that it's 8 o'clock, and so I'm going to take another half hour of your time to do a real little bit of introduction into the next section. And I apologize, overlapping topics a little bit, but I'm worried about the time. I believe it's Tuesday the 16th. I think I wrote it down on the, no, I didn't write it down. Yeah. Is it going to take you guys more than a week to do that? So it'll be due, the project will be due on the 16th. Next Monday is a holiday.
I don't know what holiday it is.
President's Day.
So the 16th, we have homework number
Yes.
I mean, 17th, yeah.
No, those are gonna get pushed back because we don't have that much time left. Those will be due on the 23rd, a week later. Okay? Thank you for pointing that out. I was very ambitious when I made this list this morning. Pacing wise, we going okay? Is everything not too slow, not too fast? Am I sort of okay with you guys? So, if you took a book, that's where chapter 2. We're going to move on to look at probability. And probability, I am having a brain freeze right now. I do believe that's chapter 11. And so that homework 5 is the beginning of probability, and it talks about something that's called the fundamental counting principle. I think everybody's probably heard of probability before. Probability is kind of figuring out what are the chances that something occurs. But we're not going to talk about that concept of probability until the 4th section of this chapter. Because when you're trying to find out the chances of something occurring, it's really important that you can count all the possibilities. And so when we look at probability, we start by looking at counting methods. And again, that first method that we're going to look at is something that's called the fundamental counting principle. And when I look at that fundamental counting principle, before we state it, I'd like to look at an example. In my example, let's say that Susie Q has 4 sweaters. And she also has 3 pairs of jeans. We're going to define an outfit as being 1 sweater. How do you spell sweater? W-A-T. I lost the T and the E somewhere in the middle. And 1 pair of jeans. Is anybody else like that? Like, is anybody else who has a hard time walking, talking, and chewing gum? When I talk and think and write, it just, the spelling gets shot to hell. Sorry about that. So, how many outfits are possible? How many outfits can she make? She has 4 sweaters that she can take around, 1, 2, 3, 4. And she has 3 pairs of pants she can pick from, 1, 2, 3. How many different outfits can she make? You're thinking 7? I'm thinking it might be a little bit more than that. I think it might be a little bit less than that. Let's picture it. So here are her sweaters. She's kind of a math geek. So she's got sweater 1, sweater 2, sweater 3, sweater 4. And with sweater 1, she can either wear jeans 1, 2, 3, so she's got 3 outfits with sweater 1. And here, doesn't she have 3 outfits with sweater 2? And doesn't she have 3 outfits? I'm sorry, this is why I teach math and not art. With sweater 3? And doesn't she have 3 outfits with sweater 4? And so how many outfits are there altogether? 12. She has 4 times 3 or 12 outfits. And that's what this fundamental counting principle says. The fundamental counting principle says that if you can choose one from n objects, and one from m objects, you have m times n choices. So I'm going to multiply to see how many different combinations I can get from there. So first example, do I need to wait a minute? Are you guys like, some people look like their hands are beginning to, yeah. I'll take a water break. Let me know when you guys are ready. People at home, can you still hear?
Yeah.
Okay, so you guys are awfully quiet. You weren't volunteering any answers. I'm just being silly. We ready for an example? So let's say we're going to a grilled cheese restaurant. All they serve are grilled cheese sandwiches. Let's say there are 4 choices of bread. Let's say there are 5 kinds of cheese. You can only pick one of each. How many sandwiches are possible?
20.
And where'd you get the 20 from? 4 times 5 is 20. When we're doing the combination 2, we multiply the number of choices we have for each. So let's say, thinking about going out for dinner. Has anybody gone out for dinner on like a holiday, like Valentine's Day, where they have like a limited menu and you get to, from this restaurant? Okay. You're going to pick a meal combo, like a 3-course meal. There are 3 soups that you can pick from. There are 10 main dishes that you can pick from. And there are 7 desserts that you can pick from. How many meals are possible? And I like the 210. Do you want to tell me where you got it from? 7 times 10 times 3, multiplying the choices. And so if there are more than 2 things, you're just going to keep on multiplying. Now, next one's tricky. Let's say I'm giving, like the end of that last quiz, a true, false quiz. It has 10 questions. Let's say you're just guessing. And even if you're just guessing, hopefully everybody knows it's better to not leave it blank, because if you leave it blank, you're getting it wrong. So we're going to say no blank. How many different ways can you answer those 10 questions? Not 20, not 100.
Infinity.
Not quite infinity, a little bit less than that.
The reason I'm thinking 20 is because 10 questions, each question you can only write true or false, right? So what am I missing?
Can I show you? Other way around. 2 times 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 2. Thankfully, I stopped at 10 because that's all the fingers I have. Isn't each question a decision? And for the first one, don't I have 2 choices? And for the second one, don't I have 2 choices? And the third, and the fourth, and the fifth, and the sixth, and the seventh, and the eighth, and the ninth, and the 10th. And so when I multiply those, you can be a little kid like me. I like doing my powers of 2 on my fingers. 2, 4, 8, 16. I'm doubling. 32, 64, 128, 256, 5, 12, and 10, 24. Or you can, with a calculator, take 2 to the 10th, and that should give you 10, 24. There's over 1,000 ways of doing it, just guessing. How cool is that? So if you're just guessing and there's 1,000 different guesses, but only one of them's got them all right. And yeah. So let's say instead I have 4 questions. Let's say they're multiple choice. And let's say each has 5 choices. How many ways can I answer? You're making 4 decisions. For the first one, we have 5 choices. For the second one, we have 5 choices. For the third, we have 5 choices. For the fourth, we have 5 choices. Because we're going to have some fun. The fundamental counting principle says we're going to multiply, which gives us 625. Let's say I have a phone number. Phone number, I'm going to include the area code. So there's 10 digits. Now, did anybody ever notice when you're dialing the phone on the area code, the first digit is not 0 or 1? Did you ever notice and even in the number itself, the phone number, the first digit is not 0 or 1? Did anybody ever notice that some numbers don't start with 1 because if you hit the 1 first, it's long distance, right? And I don't think they start with 0 yet. I know back in the day, phone numbers never started with 0 because if you dialed 0, it gave you the operator. Do they still have phone operators? Can you call and get an operator? Well, anyways, I don't think I've seen a number that starts with 0. So, how many phone numbers are possible? Well, we've got 10 digits, right? 3 for the area code and 7 for the number. So if the first one can't be a 0 or 1, how many choices are there for that one? 8. And over here, the first one can't be 0 or 1, so there's 8 choices. And then for each of the others, it can be anything from 0 through 9. So how many choices do we have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 choices for all of the others. What should I do with all those numbers? Multiply. So that gives me, let's see, 8 times 8 is 64, and then I need 1, 2, 3, 4, 5, 6, 7, 8 zeros. So what does that give us? Hundreds, thousands, millions, billions, 6 billion, 400 million phone numbers. Bam. Is anybody else's head exploding thinking about all of those? And that would just be in this country, because in other countries it's like different codes and all of that. So one more. And I'm going to shut up and have you guys figure. 640000000. Because there were 8 10s, it means we'll get the 8 0. And so now let's look at license plates. We're going to look at passenger cars and not vanity plates. Anybody like drive a car, not a truck, not a commercial vehicle, and you got license plate and you didn't pay extra for the license plate? I don't know about yours. Mine is 3 letters and 4 numbers. Is everybody else's the same, 3 letters and 4 numbers? How many are possible? Let's think about it. We're filling in 3 places with the letters and 4 places with the numbers. How many letters are there? 20 letters, right? And in a license plate, letters can repeat, right? And so there's 26 choices for the first one, 26 choices for the second, 26 choices for the third. Now let's look at those numbers. Can you have a 0 and a license plate? So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 possible numbers to fill in there. And the numbers can repeat. So there's 10 choices for each of those. What should I do with all those numbers? Multiply. Word of the day is multiply. And so when you multiply all of that out, what do you get? Nobody's pulling out a handy dandy calculating machine to help me. I got 175760000 or 175,760,000. But there's got to be more than that because people do like all of the vanity plates and then commercial vehicles have, I don't remember what it is for commercial vehicles. Does anybody know what a commercial license is? I think they have like, I don't know if it's more letters and less numbers or more numbers and less letters. And if they ran out of license plate numbers, couldn't they just add another letter and all of a sudden you've got 26 times as many? So kind of crazy. It's still a little early, but I'm seeing people packing up and looking like they're on mass overload. So, we didn't take much of a break, right? We didn't really take a break. Well, I hope I don't regret giving you 20 minutes now at the end of the semester. At the end of the semester, Megan, if you help me look really fast, we can call it a day right now. But you guys look like you're ready to call it a day. Yes? All right. We'll see you next week. Next week, Thursday. If you have questions in between time, please send me an email and ask. Hopefully, if everybody at home in the Zoom meeting can still hear me, hopefully the audio is recorded this time. And I'll scan the written notes in addition to posting a YouTube that I'll make from the recording of the class. Okay, the last class, the Zoom doesn't have any audio in it, but if you read the notes, if you have questions, just stop by my office hours.
Okay.
And there's a Zoom link in Blackboard, or, you know, as you go down the tool bar on the side, there's a link for my office hours.
Okay.
Click on that and it'll take you right in.
All right, sounds good.
Okay, have a good one. Glad you made it. Yeah, I'm glad all of you made it. So, yay. Everybody at home, are you guys all right? I'm gonna stop sharing my screen if I can, find my mouse. And I'm gonna stop recording.